With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states a metallic rod of length 1 meter has one end free and the other end rigidly clamped. The longitudinal stationary waves are set up in the rod in such a way that there are total 6 antinodes present along the rod. Now the amplitude of the antinode is simply 4 into 10 raised to the power minus 6 meters. Young's modulus and the density of the rod is 6.4 into 10 to the power 10 Newton per meter square and the density is 4000 kg per meter cube respectively. Consider the free end to be at the origin and at t is equals to 0 the particle at the free end are at their positive extremes. Now we have to find the equation describing the displacement of particles about their mean position. That is, we have to find what is the equation of this stationary wave. So let us now first try to draw a diagram for better understanding. So let us now try to understand how the stationary wave will be simply formed in this rod. Let us suppose that this AO is the total length of the rod. Now what happens is that if you make it vibrate, then the incident wave will simply move in this direction, and let this be the incident wave. Then what will happen is that there will be a wave reflected from this end, then this will be the reflected wave. This will be simply reflected wave, and you can see that due to their superposition a stationary wave will be simply formed on this rod. Now stationary wave is formed such that there are 6 antinodes, right? So A1, A2, A3, A4, A5 and A6 are antinodes, and it is given that the free end is at the origin, so we have taken x is equals to 0, right? And the particle at t is equals to 0 are at their extreme. So this is the screenshot of the stationary wave at t is equals to 0. Now let us try to, we have to find out the equation of this stationary wave. So let us first try to understand what is the equation of a stationary wave. We write the equation of this stationary wave is simply a cos kx sine omega t plus 5. This is the equation of stationary wave. This is one form of the equation of stationary wave. Now what we have to find here, we have to find a, k, omega and phi. These are the 4 things that we need to find out here. So let us first try to find out the value of k. How do you find out the value of k? You can see here we have this distance is simply equals to lambda by 2, and how many such distances are there? This is lambda by 2 plus lambda by 2 plus lambda by 2 plus lambda by 2, and we have 5 lambda by 2 plus lambda by 4. We have 5 times lambda by 2 plus lambda by 4. This will be equals to the total length of the rod. So from here you can calculate the value of lambda, comes out to be nothing but this will be 4L divided by 11. Now this is the value of lambda from here, right? So let this be equation number 1. Now you know the value of lambda, right? So next thing that we need to calculate is we need to calculate what is the frequency of this stationary wave. To calculate the frequency, what we need is we need the speed divided by the wavelength, right? So we know the wavelength of this stationary wave. Now we need to know the speed. So how do we calculate the speed of the stationary wave? With the help of Young's modulus. The speed of stationary wave is simply equals to Young's modulus divided by density. And if you put the values here, values of Young's modulus is 6.4 into 10 raised to the power 10 whole divided by the density is 4000. So this will simply nothing but this will give you that the speed of the wave here is simply nothing but 4 into 10 raised to the power 3 meter per second. Now this is the speed. We can calculate the frequency. This is first, this is second, let this be third. Now let us try to calculate the frequency. So if you put the value of speed, this is 4 into 10 raised to the power 3 whole divided by lambda is simply 4 into L is 1, and this will go up. Now here L is simply nothing but this is simply 1 meter. So we can place 1 here and then we will get frequency equals 11 into 10 raised to the power 3 hertz. Now we have found out the frequency. Now we can calculate the value of k here. So the first thing that we can calculate here is simply k equals 2 pi divided by lambda. So from here we get the value of k as 11 pi whole divided by 2. This will be the value of k. Now let this be equation number 2. We will use it later. This is equation number 2. Now what we need to calculate is we need to calculate the amplitude. So how do we calculate the amplitude? So you can see that this is the resultant wave and it is given that at t is equals to 0, at t is equals to 0, x is equals to 0, y is simply equals to a, that is the amplitude. So if you put this a, so at t x is equals to 0, this is cos 0, this will be a into 1, and here t equals to 0, this will be sin phi. So from here you can see that a and a will cancel, you get the value of phi which will be simply pi by 2. Let this be equation number 3. Now you know the value of k, you know the value of phi. What we need to calculate is we need to calculate omega. And how do we calculate the value of omega? Omega is simply equals to k times the speed. Now we can calculate from here. K we know already. This will be simply omega equals, this will be 22 pi into 10 to the power 3. This is equation number 4. Now we know all the parameters, so we can very easily write the equation of a stationary wave, which will be simply nothing but y equals 4 into 10 raised to the power minus 6. This is the amplitude cos. We can put the value of k here. So cos kx will be simply 11 pi divided by 2x into this. You can see that phi omega t plus phi is simply pi by 2, so this will be cos omega t. So what we need to write here is simply cos, and omega we have found out to be 22 pi into 10 to the power 3. So this is 22 pi into 10 to the power 3 pi t. Now we, so if we match out the option, this will be the correct option. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.